আর ওটা দেখা যাবে না, যখন গ্লিসারিন আর ইয়ে কাজ করবে, গ্লিসারিন আর এটা নিয়ে কাজ করবে। ওটা অফ করে দিন বল। তো আজকে এখানে আমরা যে কেমিক্যাল রিয়াকশন করব, পটাশিয়াম পারম্যাঙ্গানেট দরজাটা বন্ধ করে দিন। sodium hydroxide. Sodium hydroxide. Oh. Now we are adding sodium hydroxide. We are adding sodium hydroxide into the beaker. then followed by stirring the solution. We shall make the solution first. Aluminium, followed by so this is a solution of sodium hydroxide, and then followed by what we shall do over there, right? Like we shall add some aluminium. We have added aluminium, and so this is a solution of sodium hydroxide, and then followed by we have added some aluminium. Where we have collected this aluminium from the foils of medicines. Okay, now let's see what happened. Let's see what happened during this reaction. You can see that there are some efflorescences, like some bubbles are coming out from the solution. Okay, so just give me a little bit time, then followed by you will get amazed what will happen then. If we are adding extra a little bit of aluminium, then what will happen? This reaction is quite so, but when it gets started, it will reacting like a lot of heat energy will be evolved. Now you'll see that if we are putting a balloon in the mouth of this beaker, then you will see that something will happen. That means there will be an evolution of gas, and this gas is nothing but the hydrogen gas. That's quite inflammable, combustible gas. Rather, if we are putting a mastic over there, ignited mastic, then there could have been a small type of, there will be a pop-up sound. Rather, the gas will start blowing, right? The gas will start burning. Now let's see what happened to this balloon. Still now the reaction has not started properly. When the reaction will started properly and a lot of heat energy will, lot of hydrogen gas will be evolved, then you will see that some changes will be, you will see I think all of you can see the changes of this balloon, right? Okay, so this is a proof that while this sodium hydroxide and aluminum reacting with each other, then the reaction is slow. I know that. You can see that there are a lot of efflorescences. Hydrogen gas is being evolved. It has already started. Okay, so this is all about. So this is a reaction, right? Still now, as we know that this reaction, as we can see that the reaction has not started properly. Okay. Here we shall perform many chemical reactions, right? So this is the evolution of hydrogen gas. So removing this balloon. Okay, now you can see that water vapor coming out of this bottle, right? I think we can see that. Okay. So this was a reaction between sodium hydroxide and aluminium. Okay. So you can see that. Right? Okay. Next we are moving to the next reactions. Let's just continue. Next, what we are going to have right now is ফেলে দাও, এটাই ফেলে দাও, কিছু হলো ধরো। ওকে, নেক্সট now we can see that the reaction is doing very so this is a reaction between aluminium and sodium hydroxide. Sodium aluminate is being formed. Okay, so it will be done, then followed by We are going to have some reaction between HCl, HCl, and then followed by with iron nail. Okay, iron nail. So what we're doing is that we have added some water with HCl. I don't know whether the reaction will happen or not because this is a rusted iron. Now let's see what happened. Yes, it has started reacting. So what we have done, we have added HCl with iron nail. The reaction is going and the reaction is doing very well. There is an effusion of a gas, an evolution of a gas, which is nothing but the hydrogen gas. Well, we can see that, right? And this is also the evolution of hydrogen gas, and there is another reaction happening. Right? Oh, it's too hot. It's too hot. That is there is a reaction between sodium hydroxide and aluminum, and then followed by we are also having a reaction, right? Like this is okay. So let it be done. So here we will have ferrous chloride, right? Let's have another reaction. What happened when magnesium get come in contact with this HCl? Then what happened then? Okay, let the reaction to be done. So this is a copper that we have extracted last day. Okay, this is a last day. We have done some reactions and the copper. What was there? This is the original copper, original pure original copper, which we shall extract it from this. Right. Okay, next go to the next reactions. We are going to the next reactions. Okay, let it to be clean first. Magnesium strip আছে না কাঁচি নাও কাটো so again we are adding HCl to the let's see how magnesium react with the iron. Like we can see that the iron is reacting quite well. Because magnesium in the electrochemical series, magnesium is just after calcium is situated and iron is below the magnesium. Iron is situated below the magnesium, so that's why the reaction, I hope you can see that the rate of reaction is very slow in that sense. The what amount of hydrogen is get evolved. I think that is visible. Okay, right. Okay, next what we are going to do is that we are adding to the HCl. We are making HCl solution. We have diluted that acid. Okay, although it doesn't matter whether you are diluting this acid or not, because magnesium as it's situated, this is magnesium strip. Okay, or magnesium ribbon, whatever you can say. While I am putting this magnesium ribbon into this HCl solution, let's see what happens. Oxygen the attack right. So we are having a piece of magnesium ribbon, right? So we are putting this. I hope it is seen. Okay, just a minute. Right, I think right now it can be seen quite clearly. on putting this magnesium ribbon into the HCl solution. You can see that. Oh my god. I think you can see that fast the reaction is going on. How fast the reaction is going on, because there is magnesium. Now I will prefer to put into the stew rack. So this is magnesium, this is iron. So this proves that which reaction is quite faster. I think all of you can hear the sound of this reactions. Still now a little bit of magnesium strip is left behind. So that's why the HCl is reacting with this part, and they're making a MgCl2, and then followed by, and there is an effervescence or evolution of gas, and the gas is nothing but hydrogen. Right? So I think all of you can see that there is no magnesium ribbon left behind. And the little of magnesium ribbon is left behind. Okay, let's see what happened. We are adding aluminium to this with this acid. Let's see what happened. If we are adding a small strip of, what happened then? Yes, that has started already. Right. So what happened when aluminum gets inserted? Then aluminum chloride and hydrogen gases get evolved. Okay. So, but although you can see that the rate of reaction of magnesium was quite faster than that of the aluminum. That means that, and this happens due to the position of the magnesium in electrochemical series. Right? What happened when we have done the reaction between sodium hydroxide and aluminium? So this was a residue, right? This happens when sodium hydroxide react with aluminium. And what happened when we are putting a nail? It's reacting. Still, it is reacting. Still a evolution of gas. Right. Okay. Still effervescence of gases. So let this reaction to be done, then followed by, once again, what we are going to do is that we are adding HCl. We are adding H2SO4, and then followed by potassium permanganate, and a small piece of cotton will be added. Let's see what happened then. Right? Okay. Okay, now we are back with the reaction between H2SO4, potassium permanganate. Now we have, now we see that there is nothing left behind, right? So right now, so right now what we are going to do is that we are going to add some H2SO4. So where is a bottle of H2SO4? This is H2SO4. Right. We're going to add a little bit of H2SO4 into this container, and then followed by a pinch of potassium permanganate will be put it over there. And then what happened? Well, we are putting an organic substance. Let's see. It will do another. Production. Yes, sir. So first, switch on the fan. This is H2SO4. এটাকে ক্লিন করে নাও না ওগুলো এখানটা ফেলে দাও খুব গরম এটা বাবু বাইরে 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 ফেলো. So right now we are going to make some, we are going to take some, we are going to take a little bit of a drop, 1 or 2 drop of H2SO4, and then followed by what happened next. Let's see. আচ্ছা এটা হাইড্রোজেন ইভলভড হচ্ছে, একে সরাও. Okay. First of all, we need to be very careful enough while you're dealing with H2SO4. Okay. As you know that H2SO4 is a strong oxidizing agent, so we need to be very cautious about it while we're dealing with H2SO4. So we have put some piece of cotton over there. We have taken some piece of cotton, right? This piece of cotton will help us to do this experiment, right? So let me remove all the substances which are not necessary for this reactions. You can see that a small little bit of amount of this amount of H2SO4 we have taken, right? Next, what we shall do is that we shall provide this is such a reaction where a lot of heat energy will be evolved. We need to be careful about all those things. Okay, now what we are going to do is that we have added a pinch of potassium permanganate. What happened? Let's see. Okay, we can see that light is coming out of this solution. Okay, let's add a small amount of let's see whether you can see some amount of heat or not. I hope all of you have seen that, and there is a red brown color vapor, pink color vapor. Next we are going to add a little bit more. Okay. So if we are adding a little bit of potassium permanganate once again, okay. So this was a quite exothermic reaction. Start reacting once again. Okay, so give me a little bit of, you can see that little bit of potassium permanganate need to be added once again. So this happens. This actually happens. The chemical reaction is going on. Okay. Yes, there is a pink color vapor. Though is making comments like pink color vapor. Yes, there's a vapor of pink color. Okay. So this was the chemical reactions for today. Tomorrow, I think we can bring you more chemical reactions where we will see all those reactions live, what we have given in shorts. Right? Okay, till then, tada, bye.